So welcome everyone dearly to our ELOC lesson online colloquium, and this time we will have a wonderful and very kind of exciting presentation by Professor Päivi Häkkinen from the University of Helsinki. Our schedule is such that we will have opening that I'm doing now, and then Päivi will give us about 45-minute presentation, and then Päivi and Erno will be discussing about the presentation topic, and then at this point we will go into breakout rooms, and I will present you or us actually a discussion topic for that question. And that's the time, if you don't want to participate actively to the group discussion, that's a good time to fly away from our joint session. And those of us who wish to have a joint discussion, we can then go into breakout rooms and discuss. Some of us will be really lucky to get Erno and Päivi joining your groups, and then we will come back together, and then Jake McMullen will be closing the session. So that's the plan. So this is Päivi, and I have this tradition of introducing our dear speakers in numbers, and she's our number 2 in the series of Erno's former PhD students. And I was able to collect big numbers, like really big numbers from Scopus. So she's been really actively producing journal articles and book chapters and such. And also what was amazing that she has nearly 200 co-authors. So maybe it's not that far when she talks about collaboration and collaborative learning, that she has been doing herself as well, clearly. In words, so in words, at this section I had to do some research, because actually from my early age when I was a child, I used to do orienteering. And at those days, I actually ended up getting to know a little bit of Päivi's husband, Erkki. And actually, I heard about Erkki and Päivi a lot from the times when, Päivi, you were in Joensuu, and Erno was telling always that, well, there was these orienteering people that kind of, and he was very kind of clearly excited about that. I knew something about orienteering as well. So, but when I asked around, like, how are you exactly, from your friends and colleagues, there was something very common in the kind of descriptions, and that's the first one here. Like, you are extremely reliable collaborator or a loyal collaborator, and that's how you were kind of described by your colleagues. And from some pictures and from some stories from Sanna Järvelä, I know, and we know that you love to ski, I guess, in all kinds of skis, slalom and downhill skiing and cross-country skiing. All right. And orienteering, I already mentioned, that's ELO. And then the C is collaborative. That's how you are. So I really warmly want to thank you for accepting our invitation to come to celebrate with us and with Erno for his 70th birthday and amazing career. So now, floor is yours. So I'm going to let you share your screen next. Welcome, Päivi.
Thank you, Minna, for the nice piece of research and very kind words. And just minor little thing that I'm from University of Jyväskylä, not from Helsinki, but no problem with that.
Oh dear, did I say that? That's horrible.
Well, that
Just edit
happens
the
to all
video
of us. No problem.
Yeah.
But yeah, very nice piece of work. I remember you have been involved in orienteering, and as you can see from my background, I love forest. So it's also a very great honor for me to be here and celebrate, Erno, your extremely great career. And as you remember, our joint history goes all the way back to the end of '80s, I think, and to the time when I joined as a trainee, the newly established Research and Development Center for Information Technology in Education, TOTU, unit at the former University of Joensuu. And I made my doctoral thesis under Erno's supervision, and there you can see some familiar faces. 3 of us defended our doctoral thesis in the same year, 1996, and some other TOTU colleagues there as well. And at TOTU, we were immediately introduced to the international field of learning research. And that was actually something quite unique at that time, especially in the area of educational research. So we were sometimes joking with the colleagues that we are just like walking in the bibliography when Erno brought all the international guests and introduced us to gurus around the world. And that was very exciting time for young PhD students. So I'm very grateful, Erno, for you, for all those early career times, but also for the later ones. And I must say that you are not only a role model in doing scientific research, but also very sympathetic and always very constructive supervisor and mentor and a colleague, and I think all of us agree on that. So, and I must say to Erno that your intellectual curiosity is something quite amazing. You quite seldom meet something like that. But so how do I then come to this field of collaborative learning and computer-supported collaborative learning? So at the end of '90s, I got interested in this particular topic. It was during the European Science Foundation research program that was called Learning in Humans and Machines. Quite interesting, quite timely also today. So already in my PhD, I utilized some neural network methods, and in this particular research program got interested also in computational approaches as analysis methods. And especially today, when technology has rapidly developed and all the computing capacity is enormous, we all know that technology enables quite powerful ways of leaving traces of learning processes. And some of the keywords, as you know, are learning analytics and even computerized assessment. And that is something that we are going to take a look at today. And at the same time, we also have some particular challenges in the field of collaborative learning. It's not very easy to answer the questions such as how do we know when some groups perform better than other groups, or how do we get evidence of skill of collaborating, and also progression in developing this kind of skill. So actually at my current home institute, Finnish Institute for Educational Research, I'm surrounded by assessment people conducting all these large-scale assessment studies such as PISA and PEARLS and TIMSS and so on. And although I'm not coming from the field of psychometrics or from the area of educational measurement, I have been always interested in whether we could learn respectively from each other, namely we as learning scientists and CSCL researchers from the assessment studies and vice versa. So this is quite an interesting question, because in educational measurements, we are quite often talking about something, or we are focusing on assessing something that is relatively stable and quite context independent often, like individual attribute or capacity, for example. Whereas in CSCL research, we are talking something which is a very dynamic, very complex set of skills and processes. That's what makes this field very challenging and at the same time very interesting as well. So today I'm going to take a short introduction to the very recent studies and approaches that we are tackling with, and not so much on the earlier work. And this work has naturally been conducted with in many different kinds of teams and people in our own research group, but also around that. I'm very grateful for all these collaborations. So let's say that for more than 2 decades, we have now been working on collaborative learning, and as we all know, that socially organized learning activities, particularly with digital technologies, are everyday life around us. So why collaborative learning? They are quite often, this question is argued by the fact that problems in our society are more and more complex, not easily solved by the individuals. There's also a possibility to build and share ideas on top of each other's, and in that way conduct something more than only some of its parts, or the kind of simple division of labor. And quite often collaborative learning has been defined also as goal-oriented and very coordinated joint work and joint activity. And particularly engagement into and commitment into high-level cognitive and collaborative activities such as argumentation or explanation or questioning the kind of questions that seek for explanations and so on. The kind of activities that earlier research has indicated triggering particular learning mechanisms. And then quite a lot of work, and many of you are very familiar with this CSCL field, which is focusing on peer interactions and meaning-making practices and discourse around, typically with designed artifacts utilizing technologies. So quite often the aim of CSCL studies is to facilitate the kind of higher level cognitive achievements. Quite broadly interpreted, it can happen in dyads, in small groups, work teams, broader social networks, and so on. Also in informal learning contexts and online classroom environments. And as we know, many of the authentic learning situations, CSCL situations, are taking the kind of hybrid forms nowadays, combining the variety of activities, variety of technologies. So this, in general, I could characterize that the CSCL field is characterized by the fact that there's a diversity of theoretical and methodological approaches in the field. They vary, having focus on individual cognition and learning, like mental efforts and so, to intersubjective, like meaning making in interaction situations, and even to interobjective approaches in which the focus is on networks of learners and artifacts and practices, for example. So the field has gained influence from many different research traditions, and at least according to my interpretation, this field of CSCL is quite open to variety of methodological approaches and also to different explanation levels, as far as it has something to do with collaboration and learning with and around or through technologies. However, what I see is quite evident that this field has so far had quite a little to do with the assessment of collaboration as a skill. So I would like to raise this old saying that learning to collaborate and collaborating to learn. So I might claim that the focus in CSCL has been more on the latter one, collaborating to learn aspect, processes on collaboration, understanding what makes collaboration effective and so on. Whereas the capability of collaborating has been less in the focus, and particularly the ways in which this could be assessed and evaluated. So as I mentioned already earlier, the technology has enabled not only multimodal data collection and analysis for research, but also learning analytics and technology enhanced assessment methods. And now I'm going more to this third aspect, the technology enhanced assessment, and by embedded assessment, referring to the idea that the learning tasks can at the same time be working as assessment tasks. So there are already sophisticated tools and methods that have potential of tracing, analyzing and assessing learning progressions and apply this information also to improve learning. So bringing this information back to the learners, also back to the teachers. But of course, always when we talk about assessment, there's this traditional challenge that it's easy to measure narrow and easily measurable skills and knowledge, but how about more complex skills and knowledge? When we aim to assess, we need to simplify many things. So you might have seen that particularly this area of collaborative problem solving as a kind of a specific form of collaboration, it has gained increasing interest in, especially in these large scale assessment studies, such as in PISA, but also in the project that we call Assessment and Teaching of 21st Century Skills. We as an institute have been involved in this latter one, of course in PISA as well, but they have slightly different focus in assessing collaborative problem solving skills. So in PISA, first of all, it's good to notice that it's a human to agent collaboration that was assessed in PISA 2015. And in this ATC 21 project, it's human to human collaboration over the internet. and assessment of the skill through that. There's also a difference in PISA. It's more like a problem-solving approach, the kind of decision tree type of a problem-solving approach in which learners take step from after another, from problem state to another, and formulate a plan and execute it and monitor the plan. Whereas the ATC 21 type of collaboration is leaning more to the kind of jigsaw model and the interdependency between the collaborators or the participants. But anyway, in both of these projects, the focus is on individual skill of collaborating. That's what we are assessing there. But of course, the roots are on the one hand in earlier research on problem solving, individual problem solving, and then on the other hand on collaboration. And these are the influences that are in the background of these types of assessments. So individual problem solving, it's the kind of thing that the learner perceives a discrepancy between the current state and the desired goal state in problem solving. And there are many mental and behavioral processes involved in this type of activity. And then in collaboration, as I already defined it in one way, it's the joint activity towards a common goal. And the learners' activities are intertwined and interdependent from each other. So meaning that learners mutually build upon each other's. And of course, if you think about the difference between individual problem solving and collaborative problem solving, the main difference is that in collaborative problem solving, each step is made observable because they must be shared with with your learning partner if the solution is to be successfully solved. So because they are observable, they are basically also measurable if we operationalize the theoretical framework into the kind of assessment framework. So here you can see the basic framework that is behind this ATC 21 project. It's described in this Hesse 2015 book chapter, and basically has a very strong socio-cognitive approach to learning background, referring to collaborative problem solving as an ability to work as a group to solve common challenge or problem through the exchange of ideas and knowledge and resources. So we are leaning quite much in our current research on this framework from one perspective. You will see it a bit later concretely. But anyway, there are basically two broad strands or dimensions under collaborative problem solving. And there's a kind of a hierarchy of sub-skills in this framework. So under social skills, there's participation, referring to sharing information and externalizing your thoughts, then taking into account the other learners' perspectives, then social regulation, pointing to the awareness of strengths and weaknesses of the group members. And then under cognitive skills, task regulation, so concretely planning and monitoring skills for developing strategies for problem solving. And then the last sub-element is the ability to learn and build knowledge through group interactions. But this is only a rough theoretical framework, and under that there are sub-elements and indicators and so on. I will continue showing how it goes concretely, the assessment that is based on this framework. So then you naturally need to have these learning and assessment tasks. And in this case, we have collaborating intensively with the Assessment Research Center, the group at the University of Melbourne. And as part of this ATC21 project, they have developed this kind of an online assessment environment. And it consists of cloud-based learning and assessment tasks that are meant to measure the current skill level and learning progressions in collaborative problem solving. So that they are complex game-like tasks, mostly in math and science domains. And concretely, each partner here controls a unique set of resources required to solve the problem together. So there's a real need for the learning partners to collaborate. And of course, they collaborate by conducting the joint tasks, but also the communication which happens through the chat window. Then concretely here you can see a session log. So after each working session, the dyads automatically produce this kind of session logs, and the data are captured as a process stream, including a kind of action chat chains. That is the core in the form of data. And then the elements of the theoretical framework, you cannot see this very clearly, but anyway, under each sub-skill, there are these kind of, in the theoretical background, this is used to explore the log stream data to identify these kind of indicative behaviors from the data that represent these each sub-skill elements. And then after this, there's the kind of behind the scene automatic scoring process that is based on rash analysis. And so it takes these kinds of scoring algorithms, takes the process stream data as input and produces then relevant output, define the rule for corresponding indicator, which is here deriving from the theoretical background. So for example, in practice, if we code and score collaboration, it takes into account the presence or absence of chat together with the time and action sequence data. For example, when the chat occurred with respect to other actions. And then this helps us to infer to collaboration. So we are not coding or scoring here in any ways the content of the chat, but where the chat is located and how frequent it is and so on. And this scoring happens automatically. It's quite a complex process because there are naturally several combinations of chat and action that can be interpreted as evidence of collaboration. And also in every pattern of action chat possibility, there are also different combinations of player-partner combinations. So it's quite a complex procedure, but the basic idea is then to produce the kind of reporting of individual student results for teachers to be used in the classroom. So these kinds of different reports, like from individual current skill level in cognitive dimension of problem solving or in social dimension of problem solving. Or the teacher can take the kind of classroom report and see the skill levels of each individual in the classroom. Or if we have 2 measurement points, we could take a look at the progression from, let's say, from autumn to spring, and see, for example, the individual progressions in, let's say, cognitive dimension of problem solving or the social one. So basically this is aims to be a kind of a developmental approach to assessment, which focuses on students' readiness to learn and the progress towards higher stages of skill, and building up on the current stage of learning. So the aim of these reports is then try to help teachers to identify the kind of zone of proximal development or the state of readiness in these particular skill areas. So basically interpreting this kind of a test score, it's not meant to be a piece of summative information from the past or the piece of information that aims to compare different students, but it's more or less like a starting point for planning instruction further. So we have been now collecting different kinds of data with different age groups with this portal. But quite typically, we combine some other kinds of data with these skill levels that we get as outputs from this portal or assessment environment. And here's just one illustration in which we studied teacher education students and combined actually one self-report instrument that was used also in PISA background questionnaire, and that one focused on collaboration dispositions. So they didn't, these students in that background questionnaire, they didn't assess or perceive their skills, but more or less like a collaboration disposition, a kind of general attitude towards teamwork and collaborative problem solving. So actually here the basic result was it's quite typical, whatever the age group is, that social skills are typically higher as compared to cognitive skills when assessed with this environment. And social skills were positively correlated with negotiation-oriented collaboration disposition. So here you can see the main scales. There was the team leadership kind of orientation where you aim to take responsibility from the group work, and then there's a cooperative attitude, which is more or less like I prefer working collaboratively instead of just working on my own, and that kind of items. Then negotiation orientation, pretty much like referring to taking each other's perspectives into account. And this was typically, and not of course surprisingly, related to the social skills assessed by the environment. Because we are still talking about the individual level here, individuals' dispositions, individual skill of collaborating. So we have been also interested in seeing among particular age groups. For example, here we have pre-service teacher students again, and here we have first year students and their profiles in particular areas. This is conducted together with the Oulu group as part of our previous project, PREP project, in which we studied pre-service teacher students, so-called 21st century skills. And here's one example from that study, because in terms of, for example, designing group compositions for collaborative situations, we have always been wondering, for example, issues related to group dynamics, and we are naturally then start thinking about what are the things that students bring into collaboration situations, not only as skills that they demonstrate, but also as attitudes and dispositions. So here we have used a couple of different scales. It's been TRIS, these motivated strategies for learning questionnaire, and from there these cognitive strategies, metacognitive strategies, and resource management. So these all together we here call learning skills or strategic learning skills. So students answer in questionnaire to this part, but also at the same time to the ones that were exploring the collaboration dispositions. So even though we typically think that teacher students are might be quite a homogeneous group of students, and they are very highly selected group of students, good ones, and so maybe somebody might think that they are very social also by nature, and so. But here we found different profiles among these first-year teacher students. And here, for example, and there's the profile in which the strategic learning skills are assessed, self-assessed as being high, but low collaboration dispositions were represented in this group. And especially this cooperation attitude, which refers to the fact that I don't need the others, I can manage on my own, I don't prefer teamwork. And then this opposite profile here. So these had very high collaboration dispositions, but low strategic learning skills. So and of course, here this green line, this profile and high learning skills, low collaboration dispositions was associated with a better earlier school success from high school. And that is, of course, not very surprising. They are maybe used to study, and they have been assessed pretty much previously individually. But these are the things that might have some influence on when further thinking about the kind of group compositions in collaborative learning groups. And at this particular moment, we are working on this COPSOI project, which is a joint consortium with Professor Paavo Leppänen from psychology and his team. And there our interest is examining and explaining the students' differences in collaborative problem solving, but also in the other relevant 21st century skill area, which is online inquiry or information problem solving and this kind of area. Also seeing the connections between these two areas, for example, the cognitive dimensions of CPS might have connections to particular areas in online inquiry, but also exploring the underlying processes behind these two major areas. And we have quite a nice data here at the moment, but we are mostly on a way of analyzing and haven't done very much yet in combining these different data sets, because we have from the same students, we have large-scale classroom assessments measuring, for example, collaborative problem solving with the assessment environment that I just showed. We have assessed online inquiry skills, and then also some reading measures, reading comprehension, reading fluency. We have conducted a set of cognitive tests and so on. Then we have invited part of these students to the lab studies to focus on very micro level detailed collaboration process interventions, and then even, which is I think the most challenging and most ambitious aim of this project, is to see, we have conducted MEG studies and focused on neural processes of collaborative online inquiry, and maybe at some point we might be able to answer the question whether learners' neurocognitive profile could predict the performance in CPS and online inquiry. But I encourage you to follow this project. We are very intensively now analyzing the data, and I will now just take 2 snapshots. Do I still have a bit of time, Minna?
Definitely, with those words.
Yeah.
You have.
Okay, thanks. I will take a couple of snapshots of our very recent work, but this is mostly focusing on our own core area, so the CPS. And here, as a first author here, you can see a familiar person for Turku people, Shupin Lee, who is working as a postdoc researcher in our project now. And Shupin has conducted very nice analysis now, for example, on this issue, in which we have now 6th graders, collaborative problem solving processes in authentic classroom situations. And we have assessed their CPS skill levels with that Melbourne system. And then we have also focused on processes and aiming to see the connections between the skill levels and how the dyad processes look like. So here, first of all, the dyads were randomly in authentic classroom, randomly paired. So we didn't influence on that, which means that this is then based on the these paired configurations are done afterwards from the data. So basically, based on those scores in the portal assessment system, we formed 5 theoretically based profiles or paired configurations. So here you can see the HHH8, meaning active high performing pairs, means that both participants had high social skills, high cognitive skills. Then the next configuration, active compensated pairs, means that both had high social skills, but the other one from the pair had low cognitive skill, the other one having high. And then this biggest group is that both participants had high social and low cognitive skills. And then the group in which one participant represented either high or low social skills, and both had low cognitive skills. And then a very small group, the last one, in which both had low social and low cognitive skills. And then we took the log file data from the system, these action chat chains as a sequential process data. There's the amount of log file events and so on. And the order of actions indicated the sequence here, the sequence of activities. For example, if the learner is dragging to move an object from one place to another, or another type of action could be that he or she types the text in the chat box. And as we know that previous actions may potentially influence on current and future decisions, so we thought that social network analysis might be used to examine the kind of sequential interdependence of actions in this kind of process data. So we applied social network analysis for process data. So use this weighted directed networks, which means that nodes are actions and ties represent changes in actions. And there are the typical network measures that you might know: number of nodes, density, degree centralization, reciprocity, and these triadic patterns. So altogether, the pairs, these 83 pairs, differed very significantly in means of number of existing nodes. And it was an interesting result that regardless of the cognitive skill level, the pairs that comprised at least one socially active student, meaning one student with high social skill level, they typically conducted a higher number of different actions than pairs without a socially active member. So these social skills in this type of assessment seem to be in quite a crucial role. So here's just an illustration of how these individual pairs networks might look like. This is also under further development, but for example, the upper figure here represents a pair in which both had high social and high cognitive skills. And for example, the reciprocity measure revealed that the extent to which this pair revisited previous actions immediately. So it might mean that pairs in which they are very high in both social and cognitive skills, they in a way think through certain steps in advance instead of conducting too many actions back and forth. Whereas in this fairly sparse network like this, which is taken from the pair having low social and low cognitive skills. So it's a fairly simple process with limited number of actions and particularly certain triadic pattern, and which indicated that there was quite a strong repetition of previous two actions and difficulty of moving from that. So this doesn't, of course, these kinds of network approach, it gives more or less like a illustration of the whole structure of the pair interaction and also the focus on sequences and the order of sequences and patterns in sequences, but doesn't of course tell anything about the content of interaction, which wasn't focused here. But then with the same data that we have gathered with this assessment portal, I will take another example. This is the last one, which is a very micro level study conducted in the lab in dual eye tracking setting, in which we had these this very controlled lab-like setting in which gene rests. Yes, we had here in order to maximize the quality of the eye tracking data here. So actually here we have the lead researcher here is Johanna Pöysä-Tarhonen who has conducted very thorough work on this dual eye tracking, both theoretically and methodologically. And we have, of course, in the background the idea that this concept of joint attention is closely associated with successful process of joint problem solving. And particularly if joint attention is not achieved, we claim that it's difficult to establish a common ground and take each other's perspectives into account or build on ideas to each other on top of the other's ideas when solving problems. And there's already quite a lot of studies on this, that gaze following is seen to be a promising basis for joint attention behavior. And especially in this kind of tasks that we do have here, in which partners need to build a kind of a shared problem space. So it's more or less like a visual or perceptual joint attention and external object and so on. And so some of these earlier studies have also indicated that percentage of moments of visual joint attention are correlated with higher quality of collaboration. So we have just started this work and have a lot of very high quality data there, but the first steps in the analysis have focused on identifying the phenomena that we are looking for from the data, which is this levels or stage of attentional levels of joint attention behavior, starting from monitoring of attention, gradually moving to the higher levels towards shared attention. And first taking more or less like a third person or observer perspective towards your collaborator, and gradually moving towards the mutual awareness of each other's attention, and then also intentionally communicate with each other. We could find from the data all these attentional levels and also interesting dynamics between the different levels. For example, these lower attentional levels can be a foundation for building the higher attentional states. But this is a very interesting area that we would like to, of course, to collaborate with people who are experienced with eye tracking studies. And of course, we do have also in Jyväskylä people working on this. And because many of these studies focusing on gaze patterns, the quite typical approach has been to answer this where question. So taking the overall looking times at predefined areas of interest. And then if we think about the when question, you might have seen these cross recurrence plots in which a kind of a general measure to quantify temporal evolution of gaze behavior, a kind of two-time series compared with each other. So what we are aiming to do is to search for different kinds of quantifications on the basis of which we could then select the selected episodes for very detailed linguistic level of qualitative analysis. For example, snapshots of higher level collaboration and because we are all the time doing this together or in parallel with this log file data and what happens in the portal. We cannot do anything without understanding how this kind of problem solving is supposed to occur. But yeah, maybe we won't go into detail. You can then ask if somebody wants to discuss with this. But so finally, towards the end. So I have raised here some of the not maybe very typical perspectives in the field of CSCL, because much of the work has been focusing on individual skill to collaborating and thinking about what individuals bring into the situations, how it is manifested in collaboration situations, and what you can possibly take with you from that as well. But of course, in this field, maybe we could take some of the visionary perspectives at the end. So of course, this field is challenged by many things, and especially all these digital ecologies or technological landscapes of especially younger generations are all the time changing or are quickly changing, and there's a need for CSCL research also to react on that. For example, taking into account the variety of forms of social digital participation of young people in variety of media environments. What we have started taking a look a little bit is a very fancy field, of course. Somebody might say that it's hype only, but extended reality and virtual reality technologies and their potential as a kind of a new forms of collaborating and social presence. And I must say that I'm a bit fascinated about this field, whether it's hype or not, but I'm not fascinated by it only because it's possible to be a virtual meeting place in COVID times, or I'm not searching for any temporary diversion from these kinds of environments, but seriously want to take a look at it, whether it can bring some added value on engaging into learning and understanding, for example, complex phenomena that we couldn't just explore without this type of technology. And of course, you are probably very familiar with this big trend as well, that this field of learning science and learning research is also challenged by these new trendy methods to capture the data. So to combine different process methods in learning research, psychophysiological, eye tracking studies, even neural methods and brain data, and there are also different forms to capture, for example, cognition, emotion, interaction, and so on. So this is, of course, a very tempting area as well, and of course it's good to remember that to be thinking quite carefully what the real added value of these methods are in each case. So do they really bring behavior, something more to the behavioral methods in each case, and not just go in terms of trendy fashion of combining all the possible data? And for example, when we are focusing on conscious learning processes, when unconscious, and what is the baseline data in physiological methods, and also more practical things like synchronizing the data sources and so on. So many challenges I recognize, but of course these challenges are to be solved, And then last but not least, as I started from the computational methods, this is also a very trendy field, learning artificial intelligence, big data, machine learning, and particularly the natural language processing technologies, and have finally reached the state in which even Finnish language is possible to be clustered and analyzed in a way that it might help us who are dealing with the behavioral data. So with these visions, I would now, sorry if I took too much time, but like to give floor to Erno and wish him, of course, all the best for the future. Thanks for all your interest.
So, thank you, Päivi, very much for your very interesting talk, and then the rich presentation of your methods you are using, and also your ideas about the future opportunities, which was very exciting. So this field, the supported collaborative learning, is something
sorry, just a little break. Päivi, can you stop sharing the slides? So
yeah, sorry.
Yes.
Yes.
Okay.
Yes.
Yes.
Yes. So after this Totu time in Joensuu, during the maybe during 10 years after that, I was very deeply in the first kind of phase of the involved in this first phase of computer-supported collaborative learning. And it was very exciting in the beginning, but then it became a bit boring because it was very different what you are describing now, because it was mainly describing some short episodes of collaborative activities in the different technological environments, and the role of the empirical data was more kind of demonstrative, so that there were strong theories, people belonged to theories, and they neglected these data sets which were against the theory and picked up these small pieces which were supporting the strong theoretical ideas. But I know that you are very familiar for that period. But can you comment also the changes, the long-term changes in the computer-supported collaborative learning research?
Yeah, yeah, that's a very clever notice from particular time period, and I also find that, for example, the demonstration of high-level knowledge building episodes conducted in something like CISL environment, and the very trained teacher to be involved in one particular classroom, that could be an example of this kind of approach, which was I'm not claiming any CISL, or they were very pioneering work at some point. But you are right that also from my perspective, I see that we got for a while stuck into this kind of
yes.
approach. What could be the big trends then? I think that this field, at least what I see, for example, let's say from the, for example, let's say working in the editorial board of the journal IGCSEL. So it aims to break its barriers more openly towards different kinds of approaches. At least nowadays, it seems to be quite aware that they cannot be a very small group of doing exactly this, but should be like getting influences in totally different kinds of areas. But yeah, what else could we reflect from the history?
So I think what you described today is a good example what has happened, so that it's very different than this period when these kind of small episodes were picked up and then they were presented as a demonstration of the big theories. And at that time, there was, of course, this strong theoretical enthusiasm. I remember that Tim Kosman spoke about new paradigm and huge enthusiasm about things.
Yeah.
But okay, but of course there was also very innovative ideas already in the beginning, and a big part of the research was mainly focused on developing new technologies which help collaboration. And at the end of your talk, you shortly referred some new kind of possibilities, but how augmented reality and this kind of technologies could offer. But what is your opinion? Have there been some interesting new technological development to support collaboration with technology?
Yeah, well, there's of course this aspect that, as I mentioned at the end, that CSCL, in that field, we may have traditionally been used to the idea that we design technologies for collaboration, to support collaboration. And now when, let's say, for example, social media apps and this kind of things that are not consciously being designed to support maybe collaboration, but not collaborative learning. So
exactly.
have become more and more common. So they are natural phenomena around us that might call for research on CSCL, but these technologies haven't been consciously designed for that purpose. So then, of course, the question arises whether we can design something for the technologies that haven't been designed to support collaborative learning. So whether we can build support structures into, let's say, for example, that virtual reality or extended reality. If we go into some virtual space, into immersive environment, for example, and there's a space for collaboration, whether we can start building designs into that space. So I don't know whether it's not ready for collaborative learning, but it's a platform upon which we might build, and that is something that I'm interested in, and particularly at that point when that kind of technologies develop to the phase in which everybody, let's say teachers, can build designs to the easily without Unity experience or this kind of a programming experience, so that they design classroom or learning settings into the virtual reality. But of course, there also needs to be the point that I tried to raise at the end, that the added value, so that there are, for example, three-dimensional objects that you cannot just understand without going into that into that object and see it from the different perspectives and so on, not so easily in the physical world or on the desktop three-dimensional environment. And that's still something that is at the very beginning, I think.
Yes, I completely agree, yes. And there are interesting opportunities to do that. But in the very beginning of your talk, you shortly kind of contrasted two, let's say, kind of practical aims of collaboration, and particularly computer-supported collaborative learning. One is that these environments was developed for immediate learning of something. And the other idea is that by participating in these processes in computer-supported collaborative learning, we learn collaboration for future, because already 30 years ago, when this process started, it was clear that professional practices of experts and practices in many fields of society are more and more collaborative. And now it's of course clear that when dealing with the big challenges of society, nobody can individually deal with them, but we need large expert groups collaborate, joining in the processes and collaborating for solving the things. But what do you think? What is at the moment the kind of the main aim is? Do we, from practical point of view, in these research studies, and do people believe that creating the ideas for computer-supported collaborative learning, you solve the current problems in universities or school learning, or science, mathematics, history, so on, or are they more focusing on supporting the abilities to collaborate in future working life?
That's a good question. I would like to see both happening. Of course, when we are talking about the, let's say, collaboration skill or CPS, collaborative problem solving skill, you easily get the image that or an association that just like it would be a kind of a generic skill that you don't, it's of course always related to some discipline or some content domain that you are practicing the skill in interaction with something, just like the relation between metacognition and some content domain to be, or the knowledge structures in some particular field. So also here you are, I think that this is of course my impression only, that I don't know how generally the field would like to see it, but let's start from here, that I think that quite often we think that the skill of collaborating doesn't need any support. It just automatically happens like that everybody is capable of collaborating. But especially with if we take a look at the earlier studies, the challenges that have been raised by researchers in the field of CSCL in authentic classroom settings, for example, there are a lot of problems. There are problems related to group dynamics, problems related to designing really collaborative learning tasks, and even the earlier CSEL and knowledge building studies raised the question of the discourse was mostly fact-seeking instead of explanation-seeking and so on. So there are many challenges. So it is reasonable, I think, to claim that we need to support also building we need to support high-level collaboration to happen, but we might also need to support building the skill of collaborating in those situations. And what I'm particularly interested in is if I talk with teachers, no matter whether they are university teachers or in primary or secondary school setting, if I ask them, how do you know whether your learning groups, those ones are performing better than those ones, or whether these students are developing in the skill of collaboration, they don't have absolutely any evidence of answering this question or showing it somehow. So I think that in order to know whether students are developing in that, we would need tools that technology can give us nowadays for also assessing that. But I don't know whether this is at practical level, I think that there's a need. For example, I have just been having many lectures with the secondary school students, so in high school and vocational both. They are very interested in all the possibilities of, for example, learning analytics and getting the traces of their students' learning and interaction activities in a very concrete forms when I have showed them some particular examples from our studies. So,
Sure. Yes.
But I think that both we need to focus at the practical level. I don't know whether I answered your question in any.
Yes, very well. And I very much appreciate your attempt to really develop something which helps you to measure the skill development of the collaboration skills, because coming back to my earlier comments about this period when it was mostly this kind of description of some episodes, and because then even in the most interesting episodes, at the end of the articles, I always had this question: so what? If we were able to describe one interesting episode, but I don't know what are the consequences. But if we can create methods to measure if in these successful episodes or some other situations students really can develop skills to collaborate in future, then I know what really is the meaning, and I understand also theoretically the importance of that work. Yes, very important.
Okay, thanks.
So I have proposal, Minna. We have so few people now left that I think that it's meaningful to go to the small groups. But
we already made the same plan with the take in the meanwhile.
Okay.
So we are very happy to kind of open the board for the general discussion and talk together now. Like unless, of course, like you two still can continue if you have some things to talk about or something like that, like please join. But also if anyone else has questions for Päivi, then now we could continue with that way.
I have a question for Päivi, if
yes,
I may.
Please.
The thing that really popped into my head, especially once you started talking about the Roche models and all, is what have you looked at, or have others looked at? Do you kind of have a general sense of what kind of expert collaborative problem solving looks like? Like, is there a model that you work from in kind of aiming for your kids that is like really is grounded in? I mean, I'm thinking especially of expertise research, but like just in general, like, is there a thing that is expert collaboration and expert, especially, I mean, if you have CPS, like, what does that? I'm thinking also about our own teams and, you know, like, how do we collaborate better? Can we find that out?
Yeah, there is, of course, these are, even though I characterize the tasks in that assessment environment as being complex, well, they are complex to some degree, and they need the contributions of both partners, but they are anyway fairly simple in that sense that they need to be measurable. You need to split the task into, or not the task, but the elements to be assessed into sub-skill areas and indicators and so on. So it cannot be very complex. There is well, first of all, I forgot to say that the framework this is based on, that Hesse and others who have reported it, it has something like 200 academics around the world who have been working on that framework. from psycholinguistics, cognitive science, educational science, and so on. And then when it's operationalized to the assessment framework and the tasks, yes, there is an ideal model of how these problems, are supposed to be solved. Yes, and this particular environment is now actually they are running it down because there will be a new environment coming next year or during this year, which has I haven't now seen it yet, but it's supposed to be not like now we are talking here about we have like assessment tasks in the form that there are 5 tasks in the one bundle, and we have corresponding the same difficulty level of bundles. We have a few of them, so that we could because these tasks are the kind of tasks in which when you once do them, you cannot do them immediately again because you remember how you are supposed to proceed or how you solve the problems. Then you have a corresponding difficulty level of bundle that you can use, for example, if you would like to follow the progress from fall to spring, for example. But in the new one, they also had an idea to make a kind of you remember the old times they had authoring tools, a kind of a template through which teachers could make new tasks, but I don't know how it would work in this case. But there are a lot of papers in which the ideal model of this kind of collaborative problem solving is described. So if you are interested, I can send you. There are 2 or 3 Springer books like this, and several articles focusing on rash modeling, focusing on task design, focusing on everything possible about that.
Oh, really interesting. Yeah.
Yeah.
Is there like a site where you could look at some, because I'd be also just really interested in some of the problems, mostly the math ones, but it would be very interesting to kind of look into it a lot further. It seems like a really we have some interest in looking at some kind of the activities that are done sort of spontaneously, in terms of some problem solving tasks in other areas, and thinking of like maker spaces and stuff like that.
Okay.
I don't know how much. I guess most of these are still very domain specific, like that there's a specificity to them, but it would be interesting to see kind of what you have out there.
Yes.
Erno, you're muted.
Erno, Erno, you are muted.
Yes,
yes,
I know.
yes.
Yes, sir.
Okay.
So, yes, one question concerning your experience with social network analysis, because it was an innovative way to use.
Yeah, it's really cool.
And we have been doing a lot of social network analysis, but never applied it for this kind of things. And so for this kind of problems, we have used in some earlier studies the Markov chains. And if you compare now with the Markov approach, how do you think that this opens some new opportunities to get out interesting things from the data?
Yeah, actually, we have also used Markov chain for this exactly this log file sequences. Johanna has. We have one paper under preparation, but we haven't now consciously compared these yet. We should take Shupin to be involved in that as well. Yeah, of course, immediately you might get fascinated with the graphical representations of the social networks and the overall interpretation that you get. But of course, that's only one point, and the network measures, what they report, are another. I haven't thought about this very very much yet, but we actually got this idea from one paper in which social networks were used for this kind of a process data and sequential data elsewhere, not related to collaboration and this kind of a dyad level data, but
looks very promising, I think.
That is something to be taken from here and thought carefully.
And would this be a good moment for Jake's closing words? Now I can share the screen and show or to you.
Those were kind of my closing words. That was the thing that has been buzzing around in my head. I just framed it as a question. So, yeah.
Actually, I wanted to just to say that we have one more ELOC session coming this spring, and that's the Mari Murtonen's presentation in the end of May. So that did you or Jake anything else?
That was where I wanted to go with the conversation. So I was really happy to hear about all of these different aspects of the way they're measuring. It's a super fascinating field. I'm really glad we got to hear about it. So thank you, Päivi, and of course
thank you
Erno for the discussion and Minna for the organization.
Well, thank you,
Yes.
Jake, also for your help, and thank you, Erno, and wonderful, Päivi, that you came and did this with us. So I'm hoping that we can find ways to collaborate with you in the future.
Yes. Thank you very much, Päivi, for sharing these ideas with us. We very much enjoyed it.
Thank you. It was my pleasure.